This video will focus on the target. I can explain the energy changes when an electron changes orbital. At a very basic level, to understand the energy changes when an electron changes orbital is to understand the planetary model. So you remember this model came from Bohr, and Bohr was energizing samples of matter. And when he sent energy through samples of matter, like hydrogen, that sample lit up. Now, when they looked at that sample through a spectroscope, they could see distinct bands of light. And so this model came from those bands. How he explained the bands of light was the idea that an electron resides at some energy level, okay, some orbit. And electrons always reside at the lowest energy levels available. Then when you add energy to them, you excite them. And when you excite them, you make them jump up in energy because you've added energy to them. So they jump up in energy. And you can't see electrons go up in energy. Right? When they take in energy, the vacancy of energy, you don't see. But after they jump up, they get tired eventually. You can't sustain high energy forever, and they fall back down. And when they fall back down, they emit the energy difference between those two energy levels as light. And that is light that you see. That specific little packet of energy, which is called a photon or a quanta of energy, will specifically have to do with a jumping from one energy level to a new energy level. If you jump between like the first to the second versus the first to the third or the second to the third, each of those jumps would correspond to a different photon and a different little quanta of energy. Okay. For every single atom that exists, as we excite their electrons, since their electrons exist in different energy levels, you see different bands of light, and we call those bands of light an atomic emission spectrum. So to understand and explain what is going on with this jumping and light, you have to understand that light is part of the electromagnetic spectrum. Okay, so an electromagnetic spectrum is the fact that there are waves of energy that exist, and they exist within a spectrum. So the ones that you see with your eye, those are energies that are moving at a frequency between 10 to the 12th hertz and 10 to the 15th hertz. So we can look at the frequency of those waves. We can also look at the wavelength of those waves. So visible light you can see on here are about 10 to the -6 meters. That is their wavelength. So a wavelength is when it repeats itself. So a wave is a continual kind of motion or transmission of energy. And every single wave has a wavelength, a frequency, and an energy associated with it. So as I strike electrons with energy and they jump up and fall back down, they give off energy. And if they give off energy that corresponds to a wavelength of 10 to the -6 or a frequency that corresponds to visible light, you'll see it with the naked eye. Okay. So electrons do jump and fall and emit energies that don't correspond to visible light. So we have some electrons giving off infrared, we have some electrons giving off ultraviolet. Okay, it just depends on kind of what the spacing is and what the energy level difference is as they jump and fall. So again, if you were going to explain the energy differences that you see, it's the idea that electrons become excited when electricity is added, and then as they fall back down, they emit that photon. And because every atom has different energy levels available to jump between and fall down from, every single sample will have a different atomic emission spectrum. So that's the explanation. Have a nice night.